Hey everyone, let's solve some more problems. Here we have number 2. Solve the equation square root of the quantity 2x plus 15 minus 2 equals square root of the quantity 6x plus 1. We're going to use similar reasoning as we did before. The only thing is that here we have a radical on both sides, and no matter what we do, we're not going to be able to get rid of the radicals in one step. Maybe you can see that. Maybe we could add the 2 over. It's not going to do anything. However, your intuition is correct if you think that the first step we should do is to square both sides. Let's see what we get. We're going to get the quantity 2x plus 15, right? Actually, let me just do this out because I don't want to do this in my head. I don't want to confuse anyone, right? Let's FOIL this all out. I will just do this one out, right? The square root of 6x plus 1, when you square that, you're going to get rid of the radical, right? I hope we see that, okay? Well, anyway, this is going to give us radical 2x plus 15, right? We're doing the f part of FOILing, right? So that's just going to give us 2x plus 15. Now we're going to do the OI part of FOILing, right? That's going to give us minus 4 radical 2x plus 15 plus 4. Okay. So we've improved our situation, right? We used to have 2 radicals, now we've got 1. But we still do have 1. Well, now I think we go right into our previous tactics of combining the like terms, and maybe we dip into what we did for number 1, right? Where we get the radical on one side and then square both sides, okay? So what we're going to do right here, let's add the negative 4 radical 2x plus 15. Let's add 4 radical 2x plus 15 to both sides and subtract the 6x plus 1 over to the left side, okay? So we're going to get negative 4x plus 14 plus 4. So I guess we're just going to say plus 18, right? Make this a little bit closer over here. And then this is going to equal 4 times the radical 2x plus 15. Right? See, we subtracted the 6x to get negative from the 2x to negative 4x. Did 15 plus 4 is 19 minus 1 is 18. All right. Now, if you want, you can divide both sides by 4. I'm not going to do that, but you can if you like. Anyway, what we're now going to do is we're going to square both sides. So we're going to get, let's see, if we do this one out, then we're going to get 16x squared minus 144x, right? Negative 4 times 18 is 72, and you do that twice. That's the OI part of the FOILing. Plus, I believe 18 squared is like 324 or something like that. Anyway, this is going to equal 16 times the quantity 2x plus 15. All right. Let's just multiply out the right side there. This is going to be 32x plus, what's 16 times it? Well, 16 times 10 is 160. 16 times 5 is 80. So I guess we're going to have 240. Let's subtract everything over. And now at this point, it's just combining the like terms, right? We get 16x squared minus, so we're subtracting 32x. I think we're getting 176x plus, I guess when we subtract 240, we're going to get 84 equals 0. Woof. This is a little much, right? Let's divide out by 16 at this point. I think we can, not going to work out perfectly. Well, if we try to divide out by 16, that's not going to be great because 84 doesn't divide that nicely. But we can divide out by 4, I guess, right? So that'll be something. 4x squared minus 44 plus 21 equals 0. Still not the nicest thing to I mean, honestly, we can use the quadratic formula if we need to. Let's see if there's any way of factoring this. Let's see if we can factor this without resorting to the quadratic formula, right? We know it's going to be minus. All right, let's see. Well, we know that only a handful of things multiply to be 21, right? So it's 21 and 1. I actually think it's going to be 21 and 1, believe it or not, right? Because -1 times 2, -2, -42. Add those together, you get -44. So I think that actually works out okay. And I think we're left with x equals 21 halves and also 1/2. All right. Now, I suppose we ought to go back and check our work, right, just like we did before. So maybe let's just go up here. Well, I'll just keep it here. Check our solutions. Let x equal 21 halves. So we get the square root of 2 times 21 halves plus 15 minus 2 equals square root of 6 times 21 halves plus 1. Well, inside the radical. Well, by the way, that is a minus 2, not times 2. All right, well, this is going to imply that we get the square root of 21 plus 15. That is 6 minus 2 equals, okay, 6 times 21 over 2. I mean, 3 times 21 is 64. I think it's going to give us 8. This implies that 4 equals 8, which is nonsense. So maybe we should try. Let me put that a little further down here. Let's let x equal 1 over 2. And now we're going to get 2 times 1 over 2 plus 15 minus 2 equals the square root of 6 times 1 over 2 plus 1. Well, let's see, at this point, I think this reduces to 4 minus 2 equals square root of 3 plus 1, which is 2. And I think that checks out just great. So our final solution is, so x equals 1 over 2. Now again, where did that other non-solution come from? Well, it came from the fact that we squared both sides. When you square things like negatives become less relevant, and you have to be careful that you didn't improperly treat -1 or a negative number. Okay, so that's how you attempt this sort of problem. Okay. Now let's take a look at number 3. Right, this one looks all sorts of gross, not just because I have a typo, and I do apologize for that. Let's correct that by first whiting it out. I don't need that. Okay, what we really wanted was this, 2x squared. Much better, all right? We've got a 5th root, all right? 5th root, ugly. But actually, I think in this case, it might be a bit easier. Because number 1, there's only 1 radical, not 2. So instead, write it, well, let's use a thicker. We're actually going to violate one of our previous rules. Again, when we have radicals, things get a bit differently. We're going to add 2 over to the other side and get the 5th root of 2x squared, is that plus 1, equals 2. And then raise both sides to the 5th. All right, and we're going to get 2x squared plus 1 equals 2 to the 5th, which we know equals 32. Or if we don't know that, you can do 2 times 2 times 2. It's 32. Okay? 32. Right? And so then I guess we're going to get 2x squared minus 31 equals 0. Yep. I'm going to put that right. There you go, right? Not the nicest thing in the world, but we do have a difference of 2 squared. So we have that square root of 2x minus the square root of 31 times square root of 2x, root 2x plus 31, So we know that that is going to equal 0. Let me move that over. Okay, and so we know that x is going to equal, not the greatest thing in the world, right? Square root of 31 over the square root of 2, or negative the square root of 31 over the square root of 2. And while those are not the nicest answers, let's plug them in and see what we get. Okay? Check solutions. Right? Let x equal square root of 31 over the square root of 2. And this is actually kind of nice. I know we're dipping into down here, but that's okay. We're going to get the fifth root of 2 times this guy squared, which I'm just going to square it because I think it's nicer to look at, plus 1 minus 2. Well, that's going to equal, well, we claim that it equals 0. But we're really getting that the fifth root of, what is that, 31 plus 1, which is 32, minus 2 equals 0. That's correct. Because we know that the fifth root of 32 is 2. And it's not like a negative 2 either. The negative 2 is the fifth root of negative 32. With odd roots, there's only one answer. Okay, so that worked just fine. Now, let x equal negative root 31 over root 2. But wait a minute. I don't even think we need to do this all out. We know we're squaring it. We know we're squaring this when we plug it in, right? When we plug it in for x squared right here, and we plug it in for x. So actually, if we want to be a little clever and not write as much, which I certainly do, maybe go in here and do a little plus minus action and say, hey, whether or not you plugged in positive or negative root 31 over root 2, you get the same answer, okay? So x actually equals both of these guys. Okay. So I don't know. Some of the aspects of this problem are not quite as easy, right? In particular, the fifth root of 2 might be a little weird. Dealing with radicals when we factored stuff out, that's not so nice. I think that's just because I used, sort of imperfect squares. But getting it into something more familiar was definitely easier than anything we did in number 2 or even in number 1, I think. There's a bit less math there. And the reason for this is, I think there are 2 reasons. There was only one radical. And the second thing is a little more subtle. The root was odd. By which I mean we were taking a fifth root. So that meant that when we were considering solutions, we didn't have to worry about plus minus things. So I'll just say in parentheses here, raising a number or expression to the fifth doesn't give or I should say fake solutions. Maybe I should say false solutions. Less politically charged, right? Okay. Oof. Now what about number 4? That's a pretty gross one. Show me what you got. Bring it to class on Monday. We'll go over it. Thanks for watching.